Looking at this simulation, what do you see? You pause for a moment and think and observe what this simulation is doing. If you look it in different directions, you can see the effect that points and lines are being rotated about the x-axis. How do we describe this mathematically? The mathematical explanation for this simulation is the following matrix. Well, this matrix is a 3 by 3 matrix, and it has the sine, cosine values inside it for different value of the parameter t, where t is a parameter ranging from minus pi to pi in radians. What I want you to think about this matrix is, and also keeping in mind the simulation, what are the eigenvalues and eigenvectors of this matrix? If you truly understand the meaning of eigenvalues and eigenvectors of the matrix, you should be directly able to tell me from the simulation which is on the screen. What are the possible eigenvalues and eigenvectors if you see the action of a matrix over few randomly chosen points in the space? Well, one way to do is just apply the definition and get the eigenvalues and eigenvectors directly. But here we want to see things from the applied perspective and what it means to be the eigenvalue and eigenvector of a matrix. So here we have the visual effect and we also have the matrix. So the question here is taken from the GATE Data Science 2026, and the matrix, you see the effect, you already saw how it acts in the space. The goal here is to tell with the help of eigenvalues what is the possible value of t, the parameter t, for which the sum of the eigenvalues of the matrix comes out to be 1 plus square root of 2. Well, let me make it clear that the goal here is not to get the answer of the question directly, but to see what this matrix is actually doing and what the eigenvalues and eigenvectors of this matrix could be. As you already saw in the simulation, that the matrix is rotating everything about the x-axis, so anything lying around about the x-axis will stay fixed, and for some values or for some angles the rotation would be just coming back to the same point or just reflecting about the other side. And from this information you will directly able to calculate the eigenvalues and eigenvectors of this matrix. So let's come back to the question. As you see, it was just the rotation, and what the question demands was to find the parameter t for which the equation holds. As you know, the trace of the matrix is just the sum of the eigenvalues, and the sum of eigenvalues is given here to be the 1 plus root of 2. You get a trigonometric equation. Solving this trigonometric equation here directly, you get the value of the parameter t for which the condition holds, and which is the option C in this case. Well, as I said, the goal was not to show you how we solve this, but to see the effect of this matrix in practice. And this matrix is being widely used in computer graphics, in image processing, and robotics. So it's very important to know geometrically what's happening in the space when we apply this matrix to an arbitrary point in the space. Next time you see a matrix, try to visually see what its eigenvalues and eigenvectors are, and how can we see those things from different perspectives, different projections in the space.